How the moon controls the ocean, the science of tides, the eternal dance. In the vastness of space, where silence reigns supreme and celestial bodies drift through the cosmic darkness, there exists a dance as old as time itself. This is not a dance of music or movement in the earthly sense, but a gravitational waltz between worlds, a gentle, rhythmic pull that has shaped the very essence of life on our blue planet for billions of years. The moon, that pale sentinel hanging in the night sky, does far more than simply illuminate the darkness with its borrowed light. It reaches across the void with invisible hands, caressing the waters of Earth's oceans, drawing them forth and releasing them in an endless rhythm that mirrors the heartbeat of the cosmos itself. This is the story of Tidal, a tale written in water and gravity, in the language of physics made poetry. Every 6 hours and 13 minutes, the ocean breathes. It inhales, drawing its waters high up sandy beaches and rocky shores, then exhales, retreating back into its depths with a whispered sigh. This breathing is not random, not chaotic, but follows laws as precise as clockwork, as predictable as the stars themselves. The moon, our constant companion, orchestrates this symphony of water with the same gravitational force that keeps it bound to Earth's embrace. To understand this cosmic choreography is to glimpse something profound about the nature of our universe, how distant objects can touch us across the void, how forces we cannot see shape the world we know, how the very tides that have witnessed the rise and fall of civilizations continue their eternal dance, indifferent to human affairs, yet essential to human existence. In the gentle pull of lunar gravity lies a story of connection, of invisible threads that bind all things together in the grand tapestry of existence. The moon's gravitational embrace. Gravity is perhaps the most mysterious of all forces, simultaneously the most familiar and the most enigmatic. It holds our feet to the ground, yet reaches across millions of miles to touch the surface of distant worlds. In the case of our moon, this force extends like spectral fingers through the vacuum of space, finding Earth's waters and drawing them with a tenderness that belies its cosmic power. The moon's gravitational field is not uniform across our planet. As it orbits Earth at an average distance of around 240,000 miles, its pull grows stronger the closer one moves toward it. This seemingly simple fact contains within it the key to understanding why oceans rise and fall in their ancient rhythm. Imagine Earth as a sphere suspended in space, with the moon's gravity pulling at every particle of matter within our world. The waters on the side of Earth nearest the moon feel this pull most strongly, like iron filings drawn to a magnet. These waters bulge outward toward their lunar companion, creating what we call the tidal bulge, gentle swelling of the ocean's surface that follows the moon as faithfully as a shadow follows its source. Yet there is more to this story, a subtlety that speaks to the elegant complexity of gravitational mechanics. On the opposite side of Earth, far from the moon's direct influence, another bulge forms. This seems to defy intuition, but the explanation lies in the delicate balance of forces acting upon our world. Earth itself is constantly falling toward the moon, pulled by that same gravitational embrace. But the waters on the far side of our planet, being further from the moon, experience a weaker pull than Earth's center. In effect, these distant waters are left behind as Earth falls moonward, creating a second bulge that mirrors the first. Between these two bulges, where the gravitational forces find their equilibrium, the ocean surface settles lower. As Earth rotates beneath these invisible hills of water, any point on the surface passes through high tide twice and low tide twice in each lunar dia period of 24 hours and 50 minutes that reflects the moon's own stately progress across our sky. This gravitational choreography has played out for eons, its rhythm as constant as the turning of seasons, as reliable as the passage of time itself. The moon pulls, the waters respond, and somewhere in this cosmic conversation between worlds lies a truth about the interconnected nature of all existence. The mathematics of this celestial mechanics could fill volumes, equations describing the precise interplay of masses and distances, forces, and accelerations. Yet beneath the complexity lies something beautifully simple, one world reaching out to touch another across the void, creating patterns in water that speak of unity across vast distances. Now, close your eyes and picture how all of this might look from high above. Earth turning slowly beneath two invisible hills of water, the moon sailing through space like a ship through cosmic seas, its wake written in the tides below. The solar influence. Though the moon reigns as the primary conductor of our tidal symphony, it does not perform alone. The sun, that blazing furnace at the heart of our solar system, adds its own gravitational voice to the cosmic chorus. Despite being 400 times more distant than the moon, the sun's immense mass grants it the power to influence Earth's waters, creating harmonies and discordances in the eternal tidal song. The sun's gravitational pull operates on the same principles as the moon's, creating its own pair of tidal bulges as Earth orbits through space. These solar tides are weaker than their lunar counterparts, roughly half the strength, but their presence adds layers of complexity to the ocean's rhythm, like a second instrument joining a solitary melody. When the moon and sun align, their gravitational forces combine in a phenomenon known as spring tides. This name has nothing to do with the season of renewal, but comes from the Old English word springen, meaning to jump or rise up. During these alignments, which occur twice monthly at new and full moons, the combined pull of both celestial bodies creates tides of exceptional height and depth. Spring tides represent the universe in harmony, moon and sun working together to lift the waters higher than either could achieve alone. The ocean breathes more deeply during these times, its inhalations reaching further up the shore, its exhalations retreating to greater depths. For those who live by the sea, spring tides bring the full majesty of cosmic forces made manifest in water. Halfway between these alignments, when the moon and sun form right angles in the sky, their gravitational influences work at cross purposes. The sun's pull partially cancels the moon's effect, creating what oceanographers call neap tides from the Old English neafty, meaning scanty or lacking. During neap tides, the ocean's breathing becomes shallow, the difference between high and low water diminished to a gentle whisper. This interplay between lunar and solar forces creates a complex rhythm that unfolds over weeks and months. The tides grow stronger and weaker in a pattern, as predictable as clockwork, yet as varied as music. Spring tides alternate with neap tides in an endless cycle, each bringing its own character to the shoreline's ever-changing face. The sun's influence extends beyond this simple mathematical interaction. The seasons themselves play a role in tidal patterns, as Earth's elliptical orbit brings us closer to our star during certain months. When Earth reaches perihelion, its closest approach to the Sun in early January, solar tidal forces strengthen slightly, adding another subtle variation to the ocean's endless song. These astronomical cycles have shaped not only the physical landscape of our shores, but the rhythms of life itself. Countless species have evolved to match their most intimate behaviors to these cosmic rhythms, spawning, feeding, migrating in synchrony with forces that originate millions of miles away. In the interplay of moon and sun lies a reminder that life on Earth dances not just to earthly rhythms, but to the grand choreography of the cosmos itself. The precision of these patterns speaks to something profound about the nature of our universe. In a cosmos that often seems chaotic and unpredictable, the tides offer a glimpse of order, of forces following laws so exact that they can be predicted centuries in advance. This predictability has become the foundation of navigation, of commerce, of the very relationship between humanity and the sea. The rhythm of Earth's rotation. As our planet spins on its axis, completing one full rotation every 24 hours, it carries all its waters with it in a stately waltz with the cosmos. Yet, this rotation creates its own subtle influences on the tidal dance, adding complexity to what might otherwise be a simple rise and fall of waters. The Coriolis effect, named after the French mathematician who first described it, emerges from Earth's rotation like a phantom force touching everything that moves across our planet's surface. As water flows in response to tidal forces, this rotational influence deflects its path, creating currents that spiral and curve rather than flowing in straight lines. In the northern hemisphere, this deflection turns moving water to the right, while in the southern hemisphere, the opposite occurs. The result is a complex pattern of tidal currents that circle ocean basins like water swirling in a cosmic drain. These amphidromic systems, as oceanographers call them, create points where no tidal range exists at all, surrounded by ever-widening circles where the tidal range grows progressively larger. The length of Earth's day itself plays a crucial role in shaping tidal patterns. Our 24-hour rotation period creates a resonance with certain ocean basins, like the deep note of a bell finding its natural frequency. In basins where the natural period of water oscillation matches Earth's rotation, tides become amplified, creating some of the most dramatic tidal ranges on our planet. The Bay of Fundy, nestled between Nova Scotia and New Brunswick, exemplifies this resonance in spectacular fashion. Here, the bay's dimensions create a natural period of oscillation that matches the tidal cycle so perfectly that water levels can rise and fall by more than 50 feet twice each day. What begins as a modest tidal force becomes amplified into one of nature's most impressive displays of cosmic mechanics made manifest. This rotational influence extends beyond Earth's surface into the realm of the atmosphere. The same Coriolis forces that shape ocean currents also guide the paths of hurricanes and the flow of jet streams. In this way, Earth's rotation connects the tides to weather patterns, linking the ocean's breathing to the very air we breathe. The stability of Earth's rotation provides the steady heartbeat against which all these tidal rhythms play. Over geological time, the gravitational dance between Earth and Moon has gradually slowed our planet's spin, making each day microseconds longer than the last. This imperceptible change speaks to the deep connection between worlds, how the same forces that create tides also shape the fundamental nature of time itself. Millions of years ago, when Earth spun faster and the Moon orbited closer, days were shorter and tides more dramatic. The rocky shores of ancient seas witnessed tidal ranges that would dwarf even today's most impressive displays. As the eons passed, gravitational friction gradually stole rotational energy from Earth, transferring it to the Moon's orbital motion and slowly pushing our satellite further into space. This exchange of energy between rotation and revolution represents one of the universe's most elegant examples of conservation laws at work. Nothing is truly lost, only transformed, as Earth's spin energy becomes the Moon's orbital energy, maintaining the cosmic dance while subtly changing its tempo across the ages. Now, imagine yourself suspended high above our spinning world, watching the slow waltz of water and land as our planet turns beneath the pull of celestial forces, feeling the gentle rhythm that connects every drop of water to the vast machinery of the cosmos. Coastal geometries and tidal amplification. The shape of coastlines holds secrets written in stone and sand, accumulated over millions of years of interaction between land and sea. These coastal geometries act as vast natural amplifiers, taking the modest tidal forces generated by celestial mechanics and transforming them into some of Earth's most spectacular displays of gravitational power made manifest in water. Consider the funnel-like estuaries that pierce deep into continental masses, their walls converging like the bell of a cosmic horn. As tidal waters enter these narrowing channels, they find themselves compressed into ever smaller spaces, forced upward by the geometry of the land itself. What begins as a gentle rise of inches in the open ocean becomes a surge of feet, then yards, then in the most dramatic cases, dozens of feet of vertical water movement. The Bristol Channel, stretching inland from the Atlantic along England's southwestern coast, demonstrates this amplification with mathematical precision. Here, the broad mouth of the channel captures the modest Atlantic tides and funnels them into an increasingly narrow space. By the time these waters reach the Severn estuary, They have been compressed and amplified into a tidal range that can exceed 40 feet, transforming quiet mudflats into temporary seas twice each day. Resonance plays a crucial role in this amplification, like a child learning to time their pushes on a playground swing. When the natural period of water oscillation within a bay or estuary matches the tidal period imposed by celestial forces, the two rhythms reinforce each other. The water begins to slosh back and forth with increasing amplitude, each tidal cycle adding energy to the oscillation until the range reaches spectacular heights. The Bay of Fundy represents perhaps the most famous example of this resonance at work. The bay's length and depth create a natural period of oscillation that closely matches the 12-hour and 25-minute tidal cycle. Like a bathtub being rocked at precisely the right frequency, the bay amplifies the modest oceanic tides into a display that can lift water levels by more than 50 feet between high and low tide. Continental shelves add another layer of complexity to tidal patterns, acting like underwater mountain ranges that redirect and focus tidal energy. As deep ocean tides encounter these shallow platforms, they slow down and compress, their energy concentrated into smaller volumes of water. The result is often a dramatic increase in tidal range as waters approach the shore. The physics underlying these amplifications speaks to the wave nature of tides themselves. Though we often think of tides as simple rises and falls of water level, they are in fact enormous waves, with wavelengths measured in thousands of miles and periods measured in hours. These tidal waves behave according to the same physical principles that govern all wave motion, reflecting, refracting, and interfering as they encounter the varied topography of ocean basins and coastal margins. Island chains and archipelagos create complex patterns of tidal interference, where waves arriving from different directions meet and either reinforce or cancel each other. The resulting patterns can be remarkably intricate, with some locations experiencing 4 high tides per day, while others nearby experience only 1. These variations remind us that tides, despite their cosmic origins, are ultimately shaped by the intimate details of local geography. Rocky headlands and underwater ridges act as tidal focusing mechanisms, concentrating wave energy into narrow zones where currents can reach remarkable velocities. The famous tidal races found around Scotland's islands and Norway's fjords represent these focusing effects taken to their extreme, creating underwater rivers that flow at speeds rivaling terrestrial rapids. In the most dramatic examples of coastal amplification, bore waves form when rising tides encounter rivers flowing toward the sea. The collision between tidal surge and river current creates a wall of water that travels upstream, sometimes for many miles, carrying the ocean's energy deep into the heart of continents. These tidal bores, found on rivers from the Amazon to the Severn, represent perhaps the most dynamic expression of lunar influence on terrestrial waters. If this gentle vision of the cosmos soothes the mind, consider resting here more often. Subscribe to the channel and share your thoughts in the comments, a quiet echo beneath the stars. The living tides, biological rhythms. Life on Earth has danced to the rhythm of tides for billions of years, and in that vast span of time, countless organisms have evolved to not merely tolerate these cosmic rhythms, but to embrace them as the very foundation of their existence. From the smallest marine bacteria to the largest whales, the influence of lunar gravity touches every aspect of oceanic life, creating biological clocks as precise as any human timepiece. In the intertidal zones where land meets sea, entire ecosystems pulse with the rhythm of rising and falling waters. Here, life has learned to exist in 2 worlds, simultaneous aquatic and terrestrial, shifting between these realms twice each day with the precision of a cosmic metronome. Barnacles seal themselves against the drying air during low tide, then open their feathery feeding appendages as the waters return. Mussels clamp their shells tight against desiccation, while anemones withdraw into themselves like living flowers folding at nightfall. The timing of these responses reveals something remarkable about the nature of biological adaptation. These creatures do not simply react to the presence or absence of water, but anticipate tidal changes with internal clocks that mirror the moon's influence. Even when removed from their natural habitat and placed in laboratories with constant conditions, many intertidal organisms continue to follow tidal rhythms, opening and closing, feeding and resting, according to schedules written in their very cells. Coral reefs, those underwater cities of the tropical seas, time their most fundamental act of reproduction to the phases of the moon. Once or twice each year, often during the nights following a full moon, entire reef systems engage in synchronized spawning events of breathtaking scale. Millions of coral polyps release their eggs and sperm simultaneously, creating underwater snowstorms of genetic material that drift through the moonlit waters like living galaxies. This mass spawning represents one of evolution's most elegant solutions to the challenge of sexual reproduction in organisms that cannot move to find mates. By synchronizing their reproductive efforts to lunar cycles, corals ensure that the vast majority of gametes are released at the same time, maximizing the chances of successful fertilization despite the vastness of the ocean. Sea turtles navigate across entire ocean basins using magnetic fields and star patterns, but when the time comes to lay their eggs, they return to the beaches of their birth guided by lunar light. The females emerge from the waves during high tide, using the cover of darkness and the ease of movement provided by elevated water levels to reach suitable nesting sites. Weeks later, their hatchlings time their emergence to coincide with the new moon, when darkened skies offer protection from predators during their desperate dash to the sea. Fish migrations often follow tidal patterns with remarkable precision, moving in vast schools that pulse through the water like liquid mercury. The timing of these movements frequently corresponds to specific tidal conditions, spring tides that bring stronger currents and better feeding opportunities, or neap tides that offer calmer conditions for spawning and juvenile development. Even the microscopic world responds to lunar rhythms. Marine phytoplankton, those tiny plant-like organisms that form the base of oceanic food webs, often show cyclic patterns of growth and reproduction tied to tidal cycles. Their populations wax and wane with lunar phases, creating ripple effects that propagate up through entire food webs, ultimately influencing the abundance and behavior of organisms as large as whales. The precision of these biological rhythms speaks to the deep connection between life and cosmic forces. Natural selection has fine-tuned countless organisms to exploit the predictable patterns created by gravitational interaction between Earth, Moon, and Sun. In the process, it has created living calendars and clocks that rival human instruments in their accuracy and far exceed them in their antiquity. Some of the most remarkable examples of lunar tidal influence on life can be found in the reproductive cycles of marine worms. The palalo worms of the Pacific, for instance, spend most of their lives burrowing in coral reefs, but once each year, during a specific lunar phase, their posterior segments break away and swim to the surface in vast swarms. These swimming reproductive segments, filled with eggs or sperm, transform the ocean surface into a writhing mass of mating activity that lasts only a few hours before the participants die and sink back to the depths. Birds, too, have learned to read the tidal calendar. Shorebirds time their migrations to coincide with optimal tidal conditions, arriving at feeding grounds just as receding waters expose vast mudflats rich with invertebrate prey. Their feeding schedules follow tidal rhythms so precisely that ornithologists can predict bird behavior by consulting tide tables. Now, rest in the knowledge that the same forces moving through your body's water connect you to this ancient rhythm. Feel yourself part of this vast, living system that breathes with the cosmos. Tidal currents, rivers in the sea. Beneath the surface of rising and falling water levels lies another dimension of tidal influence, the horizontal movement of water masses that creates rivers within the sea itself. These tidal currents represent the ocean's attempt to redistribute water in response to gravitational forces. generating flows that can exceed the velocity of many terrestrial rivers and carve channels in the seafloor as effectively as any mountain stream. The physics of tidal currents emerges from a fundamental principle: water seeks its level. As the moon's gravity creates bulges of elevated water in some regions while leaving depressions in others, the ocean naturally attempts to even out these differences through horizontal flow. The result is a complex system of currents that ebb and flow with tidal cycles, creating underwater highways that marine life has learned to navigate with remarkable precision. In shallow coastal waters, these currents become particularly pronounced. The constricted geometry of bays, straits, and channels forces tidal flows through narrow passages, accelerating the water to remarkable speeds. The Gulf Stream, despite its reputation as a warm water river in the Atlantic, is but one of many such flows. Tidal currents in places like Scotland's Pentland Firth or Norway's Lofoten Islands can reach velocities exceeding 10 knots, creating underwater rapids that challenge even the most powerful vessels. These high-velocity tidal streams possess enormous energy that represents the moon's gravitational influence transformed into kinetic motion. Engineers have begun to recognize this potential, installing underwater turbines that harvest tidal current energy much as wind turbines capture atmospheric flows. The predictable nature of tidal cycles makes these installations particularly valuable, generating electricity according to schedules that can be calculated centuries in advance. The interaction between tidal currents and seafloor topography creates some of the ocean's most dramatic underwater landscapes. Tidal scour carves deep channels in sedimentary bottoms, while tidal deposition builds underwater dunes and ridges that migrate across the seafloor like slow-motion versions of their desert counterparts. These underwater sand waves can reach heights of several meters and wavelengths of hundreds of meters, creating a hidden topography that mirrors the complexity of terrestrial landscapes. In estuaries and river mouths, tidal currents engage in a complex dance with freshwater flows, creating zones of mixing where salt and fresh water interweave in patterns of remarkable intricacy. The density differences between these water masses add another layer of complexity to current patterns, creating stratified flows where lighter fresh water glides over denser salt water, each layer moving according to its own tidal rhythm. The ecological significance of tidal currents extends far beyond their physical properties. These underwater rivers serve as highways for marine migration, carrying nutrients, plankton, and larval organisms across vast distances. Fish have evolved to exploit these current systems with remarkable sophistication, timing their movements to ride favorable flows and shelter from adverse ones. Salmon returning to natal streams use tidal currents as escalators, conserving energy by riding flood tides upstream and resting during ebb flows. Marine mammals demonstrate similar current-reading abilities, with whales and dolphins routinely using tidal flows to assist their long-distance travels. Even the smallest zooplankton exhibit behaviors that suggest they can detect and respond to current changes, rising and sinking in the water column to catch rides on favorable flows. The formation of tidal fronts boundaries where different water masses meet creates some of the ocean's most productive feeding zones. These fronts concentrate nutrients and plankton in narrow bands that attract fish, seabirds, and marine mammals in remarkable numbers. The predictable location and timing of these fronts make them crucial feeding areas for many species, creating biological hotspots that pulse with the rhythm of the tides. Tidal mixing represents another crucial function of these currents, preventing ocean stratification and ensuring that nutrients and oxygen are distributed throughout the water column. Without the constant stirring action of tidal flows, many coastal waters would become stagnant, unable to support the rich ecosystems that depend on vertical mixing for their survival. The study of tidal currents has revealed the ocean's memory how past tidal cycles influence current flow patterns through the gradual reshaping of bottom topography. Each tidal cycle leaves subtle marks on the seafloor, and over time, these modifications alter current patterns in ways that affect future tidal flows. The ocean thus becomes a record of its own tidal history, written in sand and sediment by the passage of countless tidal cycles. Understanding these current patterns has become crucial for human activities in coastal waters. Shipping routes are planned to take advantage of favorable tidal currents while avoiding the strongest adverse flows. Fishing fleets use current information to locate productive areas where tidal flows concentrate marine life. Even recreational activities like sailing and surfing have developed sophisticated understanding of local tidal current patterns. Ancient tides and deep time. In the geological record of our planet lies a story written in stone and sediment, a narrative of tides that spans billions of years and reveals how the cosmic dance between Earth and Moon has evolved across the vastness of deep time. These ancient tidal signatures, preserved in rock formations and fossil assemblages, tell us that the gentle rhythm we observe today is but the latest movement in a symphony that has been playing since the early days of our solar system. 4.5 billion years ago, when Earth was young and the Moon hung much closer in the sky, the tidal forces that shaped our world were dramatically more powerful than those we experience today. The Moon, perhaps only 15,000 miles distant compared to today's 250,000 miles, raised tides that would have dwarfed any modern coastal phenomenon. These primordial tides may have reached heights of several hundred feet, transforming entire continental margins into vast tidal zones that experienced the full fury of lunar gravitational influence. The evidence for these ancient supertides lies embedded in some of Earth's oldest rock formations. Rhythmite-slayered sedimentary rocks that preserve the regular alternation of tidal deposition contain within their strata a record of ancient tidal cycles. By counting the layers and measuring their thickness, geologists can reconstruct not only the strength of ancient tides, but also the length of ancient days and months, revealing how the Earth-Moon system has evolved over geological time. These ancient records tell a story of gradual change driven by tidal friction. As the massive early tides surged back and forth across the young Earth's surface, they created friction that slowly robbed energy from Earth's rotation, while simultaneously pushing the Moon into a higher, more distant orbit. This process continues today, though at a much reduced rate, gradually lengthening our days by about 2 milliseconds per century, while causing the Moon to recede at roughly the same rate that fingernails grow. The implications of this evolutionary process extend far beyond simple astronomical mechanics. The changing strength of tidal forces over geological time has profoundly influenced the history of life on our planet. Many researchers now believe that the large tidal ranges of the early Earth may have played a crucial role in the origin of life itself, creating vast intertidal zones where complex organic chemistry could occur at the interface between land and sea. These primordial tidal pools would have provided ideal conditions for the concentration and chemical evolution of organic compounds. The regular cycles of wetting and drying, heating and cooling, mixing and separation that characterize tidal environments create natural laboratories for molecular complexity. Some of the earliest complex organic molecules may have formed in these ancient tidal zones, setting the stage for the emergence of life itself. As life evolved and diversified, changing tidal patterns continued to shape evolutionary processes. The fossil record reveals numerous examples of organisms that clearly adapted to specific tidal conditions, from ancient algae that show growth patterns tied to lunar cycles, to early animals that developed shells and other protective structures suited to life in dynamic tidal environments. The great mass extinctions that punctuate Earth's history may themselves be partly linked to tidal evolution. As tidal ranges gradually decreased over geological time, vast intertidal habitats slowly shrank, potentially contributing to the extinction of species that had evolved to exploit these environments. Conversely, the evolution of new tidal patterns may have opened ecological niches that spurred evolutionary innovation and diversification. Climate systems, too, have been influenced by the changing nature of tidal forces. The massive tides of the early Earth would have created powerful mixing in ancient oceans, distributing heat and nutrients on a scale that modern oceans cannot match. As tidal forces weakened over time, ocean circulation patterns evolved, potentially contributing to long-term climate changes that shaped the trajectory of Earth's environmental history. The Moon's gradual recession has also influenced Earth's rotational stability. The gravitational interaction that creates tides also helps stabilize Earth's rotational axis, preventing the kind of chaotic wobbling that might otherwise occur. As the Moon moves further away, this stabilizing influence slowly weakens, though calculations suggest that significant changes lie far in the future. Looking forward into deep time, astronomers can predict the eventual fate of the Earth-Moon tidal system. Billions of years from now, tidal friction will have locked Earth and Moon into synchronous rotation, with each always showing the same face to the other. At that distant time, tides will cease to exist on Earth, as the Moon will hang motionless in the sky relative to Earth's surface. But this far future represents only one possible ending to the tidal story. The Sun's evolution toward a red giant phase may disrupt the Earth-Moon system long before synchronous rotation is achieved. Solar tides, growing stronger as our star expands, may eventually overcome lunar influence entirely, creating a final chapter in Earth's tidal history that we can only imagine. Now, let yourself drift backward through deep time, feeling the ancient rhythms that shaped the very world beneath your feet, sensing the vast patience of geological processes that work across millions of human lifetimes. Human connections to tidal rhythms. Throughout the entirety of human history, the rhythm of tides has woven itself into the fabric of civilization, influencing not only practical matters of navigation and fishing, but also shaping the deepest structures of human culture, language, and spiritual understanding. Long before science could explain the gravitational mechanics behind tidal motion, human beings recognized in these patterns something profound about the nature of time, change, and our place in the cosmic order. Ancient civilizations that developed along coastlines invariably organized their lives around tidal cycles. The timing of fishing expeditions, the loading and unloading of merchant vessels, the gathering of shellfish and seaweed all followed the reliable rhythm of rising and falling waters. This practical dependence gradually evolved into something deeper, as human communities began to see in tidal patterns a reflection of larger truths about existence itself. The circular nature of tidal cycles, their endless repetition without exact duplication, provided early cultures with a powerful metaphor for understanding time as something that moves in spirals rather than straight lines. Each tide was both familiar and unique, each lunar month a return to familiar patterns that nevertheless carried subtle variations. This understanding profoundly influenced human concepts of history, progress, and the nature of change itself. Maritime cultures developed an almost mystical sensitivity to tidal rhythms, creating bodies of traditional knowledge that rivaled modern scientific understanding in their practical accuracy. Pacific Islander navigators could read the subtle signs of tidal flows in wave patterns and watercolor, using this information to guide their voyages across thousands of miles of open ocean. Generations of accumulated observation created navigation systems that treated tidal knowledge as both science and art. The influence of tidal thinking extends deep into human language and metaphor, the very words we use to describe emotional states, feeling high or low, experiencing waves of emotion, being swept away by feelings, reflect an intuitive understanding that human psychological rhythms mirror the patterns of tidal flow. The notion of going with the flow or swimming against the tide reveals how thoroughly tidal metaphors have penetrated human consciousness. Literature and poetry have long drawn on tidal imagery to explore themes of change, persistence, and the relationship between human affairs and natural cycles. The incoming tide serves as a metaphor for opportunity, growth, and renewal, while the receding tide suggests loss, reflection, and the inevitable passage of time. Shakespeare's famous declaration that "there is a tide in the affairs of men" captures this deep connection between human experience and tidal rhythm. Religious and spiritual traditions have also found in tides a source of profound meaning. Many coastal cultures have developed ceremonies and rituals timed to specific tidal conditions, recognizing in the regular pattern of water movement a manifestation of divine order. The twice-daily rhythm of tides mirrors the human experience of breathing, sleeping, and waking, creating natural analogies for spiritual practices of meditation and prayer. Modern research has begun to investigate whether human beings might retain biological sensitivity to tidal cycles despite our largely terrestrial existence. Some studies suggest that human reproductive cycles, sleep patterns, and even psychiatric conditions might show subtle correlations with lunar phases and tidal timing. While the scientific jury remains out on these connections, they hint at biological links between human physiology and cosmic rhythms that may run deeper than our urban lifestyles might suggest. The development of accurate tidal prediction represented one of the great triumphs of applied mathematics and astronomy. The ability to forecast tidal conditions months or years in advance revolutionized maritime commerce, making possible the precise scheduling of shipping and the development of efficient port operations. These predictions also enabled new forms of coastal engineering, allowing the construction of harbors, bridges, and other infrastructure that worked with rather than against tidal forces. In the modern era, as human populations have increasingly moved away from direct dependence on natural cycles, tidal rhythms continue to influence human affairs in subtle but important ways. The global economy still pulses with tidal timing, as ships must enter and leave ports according to water levels and current conditions. The energy industry has begun to tap directly into tidal power, creating the possibility that human civilization might literally run on lunar energy. Environmental consciousness has brought renewed appreciation for tidal ecosystems and their crucial role in planetary health. The wetlands, salt marshes, and tidal flats that pulse with lunar rhythms have been recognized as among Earth's most productive and ecologically important habitats. Their protection and restoration has become a key focus of conservation efforts, representing a new form of human relationship with tidal systems based on stewardship rather than simple exploitation. Perhaps most significantly, the study of tides has provided humanity with one of its clearest examples of how local phenomena connect to cosmic forces. In understanding how the moon's gravity shapes patterns of water movement on Earth, human beings have gained insight into the fundamental interconnectedness of existence. The tides remind us that nothing exists in isolation, that even the most distant celestial objects can touch our daily lives through the subtle but persistent influence of natural forces. If this gentle vision of the cosmos soothes the mind, consider resting here more often. Subscribe to the channel and share your thoughts in the comments, a quiet echo beneath the stars. The mathematics of celestial mechanics. Behind the poetry of tidal motion lies a foundation of mathematical precision that reveals the universe as a vast calculating machine, operating according to laws so exact that they can predict the behavior of water molecules billions of years into the future. The equations that govern tidal forces represent some of humanity's greatest intellectual achievements, transforming our understanding from mere observation of patterns to deep comprehension of the underlying mechanisms that drive cosmic motion. Isaac Newton first glimpsed the mathematical heart of tidal motion in his Principia Mathematica, recognizing that the same force responsible for dropping apples also reaches across space to lift the oceans. His inverse square law of gravitation provided the key insight. Gravitational force decreases with the square of distance, meaning that the moon's pull on Earth's near side is significantly stronger than its pull on the far side. This differential force, seemingly small when measured in absolute terms, becomes immense when integrated across the volume of an entire planet. The mathematical description of this differential force reveals elegant simplicity beneath apparent complexity. The tidal force varies not with distance itself, but with the gradient of gravitational field, the rate at which gravity changes from place to place. This mathematical relationship explains why tidal forces become stronger as celestial bodies approach each other, and why the Moon, despite being much smaller than the Sun, dominates Earth's tidal patterns through its proximity. The harmonic analysis of tides represents perhaps the most sophisticated application of mathematical physics to natural phenomena. Tidal patterns result from the superposition of dozens of individual harmonic components, each corresponding to different aspects of astronomical motion. The Moon's elliptical orbit creates variations in tidal strength that follow mathematical curves called ellipses. The tilt of Earth's axis introduces seasonal variations that trace sinusoidal patterns across the calendar year. Each of these astronomical variables contributes its own mathematical signature to the composite tidal signal. The M2 constituent, representing the principal lunar semi-diurnal tide, oscillates with a period of 12 hours and 25 minutes. The STU constituent reflects solar influence with its 12-hour period. The N2 component captures the effects of lunar orbital eccentricity, while the Kone and Un constituents represent diurnal variations caused by the Moon's orbital inclination. The mathematical beauty of tidal analysis lies in its ability to decompose the seemingly chaotic complexity of real tidal records into a finite set of pure harmonic components. Using techniques pioneered by Joseph Fourier, oceanographers can extract from months of tidal observations the precise amplitude and phase of each constituent, creating mathematical models that can predict future tidal behavior with extraordinary accuracy. These harmonic constituents combine according to the mathematical principles of wave interference, sometimes reinforcing each other to create exceptionally high or low tides, sometimes cancelling each other to produce periods of minimal tidal range. The resulting patterns follow mathematical rules so precise that tidal computers' mechanical calculating machines developed in the 19th and early 20th centuries could predict tidal heights years in advance using nothing more than gear ratios and rotating wheels. The mathematical framework of tidal theory extends beyond Earth to encompass the entire solar system. The same equations that describe lunar influence on terrestrial oceans also explain the extreme tidal forces that heat Jupiter's moon Io, driving its volcanic activity through periodic flexing of its rocky interior. They describe how tidal forces gradually synchronize the rotation of moons with their orbital periods, explaining why the Moon always shows the same face to Earth. Tidal mathematics reveals the deep connection between apparently disparate phenomena. The equations that govern ocean tides are mathematically identical to those describing the behavior of the solid Earth itself, which deforms elastically under lunar influence by amounts measurable only with the most sensitive instruments. The same mathematical formalism explains atmospheric tide-subtle pressure variations that cause the atmosphere to breathe in rhythm with celestial motion. Advanced tidal theory incorporates the effects of Earth's rotation through the mathematical machinery of the Coriolis force. This rotational influence transforms simple tidal oscillations into complex circular motions called amphidromic systems, where tidal waves propagate around ocean basins like cosmic whirlpools. The mathematics of these systems reveals how local tidal patterns depend not only on astronomical forces, but also on the specific geometry and dynamics of individual ocean basins. The numerical modeling of tidal flows represents one of the most computationally intensive applications of fluid dynamics. Modern tidal models solve the complete Navier-Stokes equations of fluid motion on computational grids containing millions of points, calculating the three-dimensional flow of water in response to tidal forces, while accounting for bottom friction, density variations, and the complex geometry of coastlines and seafloor topography. These computational models have revealed the ocean's hidden architecture, the network of tidal energy pathways that carry lunar influence from the deep ocean to coastal waters. Satellite measurements of sea surface height have confirmed mathematical predictions about how tidal energy propagates across ocean basins, creating global maps of tidal energy flow that reveal the ocean's response to celestial forcing in unprecedented detail. The mathematics of tidal prediction has evolved from Newton's simple force laws to encompass relativistic corrections that account for the effects of Einstein's general relativity. These corrections, though tiny, become measurable over long time periods, adding subtle shifts to tidal timing that reflect the deep structure of space-time itself. In the most precise tidal calculations, even the gravitational influence of distant planets contributes measurable effects. Modern harmonic analysis can extract from tidal records not only the standard astronomical constituents, but also subtle signals reflecting climate variations, sea level changes, and even the effects of large earthquakes on Earth's rotation. The mathematical techniques developed for tidal analysis have found applications throughout science, from the analysis of stellar oscillations to the detection of gravitational waves. The precision of tidal mathematics offers a profound lesson about the nature of scientific understanding. In the ability to predict the exact height of tomorrow's tide lies proof that human beings can comprehend the fundamental workings of the universe, can discover mathematical laws that operate with clockwork precision across the vastness of space and time. The same equations that describe today's tides will remain valid billions of years into the future, representing eternal truths about the mathematical structure of reality. Now, let the elegant precision of these cosmic calculations wash over you, feeling the mathematical harmony that underlies all natural rhythm, sensing the deep order that connects the smallest wave to the grandest celestial dance. Epilogue: the eternal return. As consciousness drifts toward the peaceful shores of sleep, let the mind rest upon this final understanding. The tides that have risen and fallen throughout this meditation will continue their ancient rhythm long after these words fade into silence. Tomorrow's tide is already written in the orbital mechanics of Moon and Earth, predetermined by forces that began their dance billions of years ago and will continue until the end of time itself. The water that touches every shore carries within its motion the memory of cosmic beginnings, the gravitational signature of a universe still expanding from its primordial birth. Each wave that breaks upon the sand connects this moment to the deepest structures of existence, to the fundamental forces that shape galaxies and guide the paths of stars. In the gentle rise and fall of ocean waters lies a meditation on the nature of time, itself not as a linear progression from past to future, but as a spiral dance where each moment contains echoes of all previous moments while pregnant with infinite possibility. The tide that floods the shore tonight carries the same water that witnessed the first stirrings of life on Earth, that has evaporated into clouds and fallen as rain countless times, that has been locked in ice and freed by warmth in cycles as numerous as the stars. The moon, faithful companion through all of Earth's long history, continues its patient orbit, pulling at the waters with the same gentle persistence that has shaped the face of our world since the beginning. Its phases mark the passage of months as they have for countless generations, its gravitational embrace creating the rhythm that has become the heartbeat of the living world. Somewhere in the darkness, a sea turtle emerges onto a midnight beach guided by lunar light and ancient instinct. Somewhere else, coral polyps prepare for their annual spawning, their timing synchronized to phases of the moon with precision that rivals atomic clocks. In tidal pools around the world, countless creatures open and close with the rhythm of the waters, their lives choreographed by forces that reach across the void of space. The same gravitational influence that moves these waters flows through every molecule of moisture in the human body, connecting each person to the vast machinery of the cosmos. In the pulse of blood through veins, in the rhythm of breath, in the cycles of sleep and waking, the patterns established by celestial mechanics continue to operate, binding all life to the greater rhythms of the universe. As sleep approaches, carried on waves of deepening relaxation, let consciousness merge with these eternal patterns. Feel the gentle pull of lunar gravity, subtle but persistent, connecting this moment to the infinite dance of worlds. Let the steady rhythm of tidal breathing in and out, rise and fall, Flood and ebb carry awareness into the peaceful depths where all boundaries dissolve. The tide pools of dream await, where consciousness can drift like water finding its level, where thoughts become as fluid as the sea itself, where the boundary between self and cosmos dissolves like salt in infinite water. In this space beyond space, time moves with the slow patience of geological change, and every breath becomes synchronized with the eternal rhythm of tides. The moon continues its journey across the darkening sky, pulling at dreams as it pulls at oceans, creating tides of sleep that follow the same ancient laws that govern water and stone. Rest now in the knowledge that this rhythm will continue through the night and into the dawn, that tomorrow will bring new tides as surely as it brings new light, that the cosmic dance between Earth and Moon provides a foundation of stability beneath all change. Let consciousness ebb like a tide, returning to the depths, carrying with it the peace of understanding, the calm that comes from recognizing one's place in the vast symphony of existence. The waters of awareness flow back to their source, back to the oceanic depths of dreamless sleep, where all individual drops merge with the infinite sea. The tides will continue their eternal return, marking time with liquid precision, breathing with the patience of planets, dancing to music too vast and slow for human ears to hear. In their endless circulation lies the promise of renewal, the assurance that every ending contains within it the seeds of new beginning, that every ebb carries within it the potential for flow. Sleep now, cradled by forces older than mountains, rocked by the same rhythms that have soothed Earth's waters since the moon first hung in the sky. Let the cosmic lullaby of gravitational music carry awareness into the deepest rest, where dreams and tides follow the same eternal laws, where consciousness merges with the infinite ocean of being. The last wave whispers against the shore, carrying its cargo of starlight and salt back to the depths. The moon sets beyond the horizon, but its influence remains, written in water and stone, in the pulse of life and the rhythm of breath. The tide turns, as it always has, as it always will, in the eternal return that binds all moments together in the endless dance of existence. Rest in the eternal return of tides and dreams and the infinite peace of the cosmic sea.